Okay, today we're going to talk about sketching y equals ax squared plus bx plus c. You've had experience, you've worked on the Desmos exercises, so you've explored what this looks like. So, but we want to do it without a calculator, just talk about it a little bit. So we know that this is a parabola. The shape is a parabola, and how we would do this old school was, I'd give you, a table of values, and you'd plug them into the equation, and then you'd get like a picture, and it would either, look here are the points you plot, and then, maybe it would look like this. Either way, these are parabolas. So, what are some things that you notice about it? First of all, there's one change in direction. Now you notice with the line, it was either increasing, decreasing, it stayed forward, no change, or it just went straight up. But with the parabolas we're studying in this class, it's either, so we see there's one change in direction. Now there's two possibilities. First, when I say if a is greater than 0, we have a smile. The first one. Once again, just a small little note. The parabola could cross the x-axis in two places. It can cross it in one place, or it doesn't have to cross it at all. We'll talk about it another lesson. So it's a smile. That means it's a smile, and we saw that it decreased and then it increased, which means there's a minimum point. Minimum. The other type of parabola was when a was less than 0. And I call that a frown, like a frown, sad face, a frown. And it kind of looks like this, right? So the parabola increases, and then it decreases, which means here is a maximum. There's a maximum value here. Something just to think about, I want you to investigate what happens to the parabola. So what happens to the shape of the parabola as a gets closer to 0? That's what I want you to investigate. We're not going to really study it until we get to transformations, but I want you to explore. I want you to keep everything the same, but just increase a. Get it closer to 0. What's happening to the parabola? And then move the value away from 0, maybe on the negative and positive side. Okay. So what else? Well, you notice that C is always the y-intercept. And you could test it out, x equals 0. So we know what is the coordinate with the y-intercept. We know that x equals 0, and so that y equals a times 0 squared plus b times 0 plus c. So y equals c. That's always the y-intercept. Okay. Good. Next. Now, in the Desmos exercise, I also asked you to graph a line called I asked you to graph x equals negative b over 2a. And this is known as the axis of symmetry. And every single parabola has this. The idea that I can take this parabola, like when you're kids in elementary school and you make Valentine's Day cards and you cut out the heart, right? And then, I'll show you actually. This is the idea. So I got a piece of paper. Let's use pink, right? So the idea is the axis. You get a piece of paper, right? And then you draw like half a heart on it. This is how they make hearts for Valentine's Day, right? You draw half of it, and then you cut it out on the axis. So you cut that out on the axis, and the idea is you unfold it, and you have the heart. And this is known as the axis of symmetry. You can fold it onto itself. So, parabolas have an axis of symmetry. We saw in the Desmos exercise that it had the equation of x equals negative b over 2a. And I'll just show you what it looks like. This is the idea. It's here. Every parabola has an axis of symmetry. Every parabola can be folded onto itself. So that's another important thing we want to find. Right? And so, yes. So, the parabola can fold onto itself. Now, this is kind of interesting because if you think about it, this is where the turning point is. So on the axis of symmetry is where we find the turning point. Once again, right here is the minimum, and right here is the maximum. It occurs on the axis of symmetry. So, we know the turning point, it's a point, right? And we know it's an y value. So the question is, we know how to find the x value. So the x value is from the axis of symmetry. To find the y value, substitute this x value into the original equation. Substitute x value into original parabola. Excuse me. Okay, let's jump right in and let's sketch some parabolas. How about good. Sorry. Let's jump right in and sketch some parabolas. Pardon me. First one, y equals x squared minus 6x plus 4. X squared minus 6x plus 4. So we just want to sketch this. As I said before, you've done this in Desmos. Let's see if we can do this by hand. Some of you are taking analysis next year, and you're going to need to know how to do this. First of all, what is it? Well, it's a parabola. It's a smile, which means there's a minimum. What else? Oh, I can quickly see that the y-intercept is 4. I can quickly see that. Well, what's the next two things I need to find out? I need to find out the axis of symmetry, and I need to figure out the turning point. Well, the first thing we're going to do is I'm going to figure out what my coefficients are. Well, the A is 1, the B is negative 6, and the C is 4. Therefore, I can easily find the axis of symmetry. This is a line. You have to write it as the equation of a line. So it's x equals negative b, 6, over 2 times 1, which is 6 divided by 2 is 3. You have your axis of symmetry. You know it's 3. Now I can find the turning point. Can you see that down there? Yeah. How did we say we would find the turning point? Take this 3 and substitute it back in the original equation. Y equals 3 squared minus 6 times 3 plus 4. 9 minus 18 is negative 9 plus 4 is negative 5. Perfect. Now we're ready to sketch. Now we're ready to sketch. I'm going to draw my axes. Let's get some points down. I know what to expect. I know it's going to be a parabola. I know it's a smile. I know my y-intercept is 4. I know my axis of symmetry is x equals 3. You have to know how to do that. I know that the parabola is a smile, and I just don't know where it crosses on the axis of symmetry. But I do know it crosses down here at negative 5. And so this is a sketch. It's not a Desmos graph, so you know what? I'm going to make it look something like this. And now I've just sketched a parabola. In another class, we are going to be figuring out exactly what these y-intercepts are. So, these x-intercepts. That is the solution to the equation of this solution to x squared minus 6x plus 4 equals 0. But that's another class, not for today. Let's try another one. Try this on your own. Y equals negative 2x squared plus 8x plus 7. Let me say it again. Y equals negative 2x squared plus 8x plus 7. I'll put it on, yeah, let's go back. Let's go to the other board. I think I'm going to take a picture. Let's see. Okay. Let's see. The equation is y equals negative 2x squared plus 8x plus 7. Okay. Shut your computer off. Think about this. Now, let's go, sorry. Okay. What do I have here? Well, I know it's a parabola. I know it's a frown. It's a frown, so I know I have a max. What else do I know? I know the y-intercept is 7, and I know my a is negative 2, my b is 8, and my c is 7. Okay. We're going to need this 7. We're going to need this for something else a little bit further, but I am going to still write it down. Let's see. Well, I know that every parabola, what's the next thing? I need my axis of symmetry. My AOX is an equation, x equals negative b over 2 times negative 2, 8 divided by 4, negative 8 divided by negative 4. I knock the negatives out. If there's a negative up there and the bottom, they get knocked out, canceled. Final answer, 2. 8 divided by 4 is 2. Now I need my turning point. Well, we said plug it back in the original equation. Y equals negative 2 squared plus 8 times 2 plus 7. Well, 2 squared is 4 times negative 2 is negative 8 plus 16 plus 7. 8 plus 7 is 15. So my turning point is the point to 15. Now I think we're ready to sketch. Draw my axis. Try with a ruler. I know I get lazy sometimes, and I'm really quick and I want to write. Take your time. Use a ruler. What's going on here? Well, You know what? Sorry. I need to be a little more near. I apologize. So, let's see. Here we go. This is better. Let's see. So, I know that I have a parabola. It's around my y-intercept is 7. And I know my axis of symmetry is at 2. X equals 2. This is 7. This is x equals 2. Please remember, this is a sketch. Like, this clearly, if this is 7, that cannot be 2. This is not a good graph. It's a sketch. What's the turning point? 2, 15. So we know it looks something like this. It's not, and you'll see in decimals will give you the better look. But we know I could sketch this. I know what it looks like. Once again, so this is perfect. I have my axis of symmetry, my turning point, it was a max, and the x-intercept was here, and we will, in another class, we will find these x-intercepts. Whatever they are, we're going to find them. Next example. I would like you to look at the equation. Y equals x squared plus 4. Y equals x squared. Y equals x squared plus 4. It looks a little different. It's still a parabola. It is a parabola because I have the x squared. Y equals x squared, blah, 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 blah. I have a parabola. In the same way that we saw like an x and a y equals 3x, or 2y minus 3x equals 8. You know, same thing here. You're seeing the y and the x squared. We have a parabola. We know that it's a smile. So we have a minimum. So you might say, well, Mr. Ehrlich, where's the mixed numbers? Well, we have a constant here. So we know the y-intercept is 4. But then what's my a, b, and c? Well, my a is 1. My a is the number in front of the x squared term. And I know my c is 4. My question is there a b? Well, there is a b term. This is technically, x squared plus 0, x plus 4. We don't, if it's 0 times x, we leave it out. But it is there. I need that b. Okay. What's my axis of symmetry? It's equal to negative b over 2 times 1. Well, negative positive 0 is still 0. X equals 0. So once again, if you think about it, this line was x equals 2. X equals 0 is going to be along the y-axis. And it's interesting. Good. Let's get it. If the axis of symmetry is 0, what is the turning point? Okay. Y equals 0 squared plus 4. So y is 4, and therefore the turning point is 0, 4. Not a coincidence. Or in this case, it is a coincidence that the turning point is the y-intercept. So if you notice parabolas that look like this, without a b term, and yeah. And if a is 1, the turning point is equal to the y-intercept. Ignore that. Let's sketch a graph. Let's sketch our graph. Okay. Let's see. First, I'm going to plot. I know I have a parabola. It's a smile. I'm going to plot y equals 4. I know my axis of symmetry is y equals 0. I apologize. My axis of symmetry is x equals 0. And my turning point is the same place as this is also my turning point. I guess it is a coincidence for this problem. So the question is, what does it look like? Well, it's a smile, so it's going to look like this. Good. Last problem, and then we're done. The last problem we want to graph is y equals, so let's see, y equals negative 2x squared plus 50x. And so you're looking at it, you say, okay, Mr. Adler, I'm going to try this on your own. Okay, we're back. We know it's a parabola. We know it's a frown. So we have a max. Let's see. What's the y-intercept here? Well, we have a number in front of the x squared. We have a number in front of the x term. There's nothing here. Well, there's always something there. It's technically 0. The y-intercept equals 0. Well, so the a is negative 2, the b is 50, and the c is 0. Good. What else? Well, let's find the axis of symmetry. The AOS, x equals negative b over 2 times negative 2. That equals 12.5. Obviously, you need your calculator. So what's the turning point? Well, you plug it back in the original equation. So negative 2, 12.5 squared, plus 50 times 12.5. Final answer, 312.5. Let's take a sketch. Let's make the sketch now. So I'm going to do it over here, right? And we're going to plot the y-intercept, which is at 0, 0. The axis of symmetry is at 12.5. Can you see that on the screen? Let me use pink. The axis of symmetry, x equals 12.5. I know the turning point is at 312. You know what? Sorry, So I know my parabola looks like this, but you know what? I'm going to start at 0 because I want you to imagine that this is time and this is height. And so I'm going to start at 0, 0, and I'm going to go up to my max and go down. And I'm going to stop there because I want you to imagine this is the height. So I have a couple of questions I want you to think about. I want you to make up a story about what this is that went up to the max and came down. I want you to, so what is this situation? I want you to make up a story. And I want you to know, when does it reach the max? I want to know, what is the maximum height? What is the maximum height? When does it reach the max? What is the maximum height? And something a little advanced for today. How long does it take before this object comes back to the Earth? That's what I want you to think about. And that's it.